right. Are we ready to go on to chapter 4? Just about getting in. Any marketing majors? 1. Marketing majors? 2, 3, 4. That's it. All right. This is an example. By the way, to get you prepared for chapter 4, I want you to realize where we're heading. Everything we've done up to this point is now being all put together, and this is where reality hits. My goal is twofold. When you're out in the real world, before you get into a management position where you may have an opportunity to really want to use linear programming, it's going to be a few years. But here's the biggest mistake people make when they finally get to a point where they can maybe use this stuff in management, is putting together your objective function and your constraints and identifying your variables and what they are. If you don't do that correctly, it will never work for you. So that's number 1, that you have to understand how to put this stuff together. And then number 2 is, I got to make sure you truly understand how to read that output, how to analyze what the output is. Especially now, we got to get to analyzing the slack and surpluses and how we can utilize that to make better decisions. So this is where we're headed. So, from this point on, you have to identify the variables. They're not going to be given to you. You have to determine how many variables exist, how many decisions are in the story you're reading. You have to write all the constraints based on the variables you came up with and your objective function. And then you have to take all that information, plug it in either software or Excel, and you've got to come up with an output, and then you've got to answer questions to the output based on your analysis of it. We've got to put everything together now as if you can do it all. Starting with an example, you're working for an advertising firm. You've now just been promoted to management to where you're going to be the lead contact person with a team of maybe a couple people to help you for a new client who wants to do this advertising campaign. But they have certain needs that you've got to make sure get met. And the bottom line is they want to, it's either keep costs as low as possible, or they want to reach as many people as possible, or they want the highest quality index, and advertising is a quality index based on whether you're using newspaper or TV or radio or something like that, which you're about to learn. So as we read this, you need to start thinking, what's the decisions that have to be made in the story, and how many decisions are there? That's where I want you to go to start with. Media selection. That's what you're doing with this client. They said, here's how much money we have, here's our objective, here's some certain things we want included. Now you come back and make a presentation to us, advertising firm, as to how you would utilize this money for this campaign. How many of this or that, you tell us, and then we'll give you a PO. Get used to that. Purchase order, that's how everybody in business promises to pay. Here's a purchase, it's like cash. Did you get the PO? Yes. We're in business. Start creating. We're getting paid. There's going to be some things they ask for, which you're going to write constraints and like restrictions. They're going to ask either, in fact, the objective could be maximizing the reach, maximize how many times it plays, quality exposure, it's that quality index number I talked about. Now here's the story. Relax and enjoy Lake Development Corporation, this development company, get a hold of you, a marketing firm, which is called Boone, Phillips & Jackson. This is where you're heading to be. You're working there. This is your project as an advertising manager. The primary market for the lakeside lots and homes include middle and upper income families within approximately 100 miles of development. So they got this land, they put the roads in, the curbs, they ran the sewers, and all these empty lots are there. They employ your advertising firm to design a promotion campaign. Now, there's a whole story, but I just gave you the part of the story. They said, we want you to have a $30,000 budget. Does this mean you spend all $30,000? No. No. Matter of fact, you go back to a client and tell them you don't even need all $30,000. That's a big client looks at that like, because any experience I've ever had with marketing, including I had a short period of time in my career was in marketing. Marketing spends every penny, and they always spend more. It's a different philosophy in marketing. It's like, how much you give me to spend, I'll spend it all. Every penny of it, and I need more. And I'm going to come back to you and ask for more. That's kind of been my experience. Reach. They said, whatever the combination of ads you're going to do, we need to reach at least 50,000 potential customers. So certain kinds of advertising have certain amounts of audience that it usually reaches. And we want no more than $18,000 spent on TV. You're going to see all the options available, and out of those options, whichever ones represent TV, no more than 18,000. Less than equal, greater than equal 18,000. Less than equal, no more than 18,000. Right, that one so well. At least. Now here's the combination. I don't want you to spend more than 18,000, but I do want TV ads, and I want at least whatever way you're doing TV ads, I want at least 10 of them. So you already know some of the constraints. At least 10, greater than equal to 10. Or no more than 18,000, less than equal to 18,000. What else? $30,000 budget. Less than equal, greater than equal, or equal? Less than equal, $30,000 budget. And 10, no more than 18,000. Reach 50,000 people. At least 50,000 people. Less than, greater than? Greater than 50,000. This is how you attack these constraints. They kind of jump out at you. I always jump into the right-hand side because I haven't even decided what the variables are yet. I haven't figured out what they are. But all of these limitations right here are either less than equal, greater than equal. You can get the right-hand side to them. Says the advertising firm, that's you, collected data on the number of potential customers reached, the cost per advertisement, the maximum number of times each media happens to be available, looking at all kinds of different media, the exposure quality index, rating for each of the, oh, here we go, for each of the 5 media. That's a hint right there. The quality rating is measured in terms of exposure quality unit, a measure of relative value of one advertisement in each media. This measure is based on your company's experience in the advertising business, takes into account factors such as audience demographics, their age, their income, education, and image presented, and quality of the advertising. So, here it is. If you do some daytime ads, potentially reach 1,000 customers, it's going to cost $1,500 for each one. There's only 15 available for the time period we're going to do this advertising blast, and it has, each one has an exposure quality rating of 65. My hint is, the quality rating, the higher it is, the better the quality. Meaning the kind of audience it's reaching for the target, compared to the target audience, you're reaching mostly those type of people who might buy plots to build houses on. Now you have evening TV, costs a little higher, reaches more, possibly more customers, and so on. What about the rating? It's much higher also, isn't it? It's really high. It's the highest one. Daytime or daily newspaper full page ad. There's how many people it can reach. The cost is significantly low. So if you're looking at cost per potential customer, that cost is a lot lower than the other. Excuse me. Maximum you could do is 25 in a month. This is going to be a month deal, and exposure quality 40. Then you have Sunday newspaper. You know, on Sunday you get that little magazine newspaper in the middle. Is that a whole page? A half a page in color. 2,500 people possibly, $1,000 each. 4 is also available because there's only 4 Sundays in the month, and 60 is the rating. Then you have radio. TV, newspaper, Sunday newspaper magazine, and radio. How many decisions do you think there are involved in this? 5. What are they?
Daytime TV.
What about daytime TV? How many daytime TV ads are going to be in this bunch of ads we're going to do? In the combination of the optimal solution is how many daytime TV ads. And you were going to say
Evening TV.
But what about evening TV?
How
How
many?
many we're going to do on evening? Give me 3.
How many ads would be in the newspaper?
Full-page newspaper. 4.
How many ads are Sundays in newspaper?
Exactly 5.
How many ads?
How many radio ads? That's right. There's 5 decisions. You make any different 5 variables you want to make. X1, X2, X3, X4, X5 if you want. M, N, O, P, Q, whatever. And you start, I just put my variables right there. And then you relate those variables to each thing. Let me, for example, what is this 18,000? What is that? Is that 18,000 ads? What is that? How much what? say it, someone said it. Ashley, I couldn't hear you. How much, the max we want to spend on TV. That 18,000 is money. So when I put my variables on the left side, representing what we're spending on TV, my variables represent how many TV ads. I got to convert it to money because the right side's money. All right, so I'm losing. Is that what that was?
Oh, no.
Okay, you ready? Where do you see money here that represents these decisions? Say it again. Yes, cost. So you would put the cost of whatever's over here with the variables. You've got to put that cost with it because this is cost. Let's look at what's this 50,000? What does that represent?
Customers.
How many potential customers we want to at least reach? Do you see potential customers here?
Yeah.
You got to put the variables on the left side that are being talked about on that 50,000, but you got to convert those variables to represent the people being reached. So whatever variable you're using for daytime TV, it's got to be multiplied by 1,000. Plus, whatever variable you use for evening TV, times 2,000, and so on, has to be greater than or equal to 50,000. So that's my hint that kind of writing these, now that you're doing your own variables, is that it's not just the variables on the left side on some of these, it's the variables times something related to whatever the right-hand side is. If it's money, this is money. If it's potential customers, potential customers. Let's just finish. Is that the budget? That's money again. And the 10 is just the number of ads. We want at least 10 TV ads. So the left side, the variables represent number of ads, so there's no change that has taken place at all. The objective, we found out from our customer, do I have it on here? I don't. They want, I gotta try to remember here, they want this. They want the quality exposure index, however many ads you're gonna do, they want this to be maximized. So for every ad, you gotta have the exposure quality number to it, and add them all together, and that's what we want maximized. Think about the variable. Let's call this x1, 2, x3, x4, x5. Okay. Let's start with our objective function. Max or min? Max, because I said the company you're working with said they want to maximize whatever combination of ads you're going to do. They want to maximize that exposure quality. So I'm going to write MAX. What number do I put with X1 daytime TV?
65.
What is it? 65? 65 X1 plus
9.
that's a 1 plus 90 X2. I'm going to lose you. I'm going over here now. Plus what's the next one? 40 what? Just 40?
Yeah.
40 X3 plus 60 X4 plus 20 X5. There's the objective function right there. We took each variable. Excuse me. Don't forget, the variables represent how many we're going to do of each ad, but they want to maximize the quality index, so we got to multiply the quality index numbers for each ad. Let's say we're doing one of each ad, and that spends all 30,000. The quality index then would be 1 times 65 plus 1 times 90 plus 1 times plus 1 times plus 1 times. But it's not going to be one of each one. It's going to be a combination of them. But when you look at the objective function value, it's going to be the highest quality index we can put together and stay in these limitations for this client. Here's our variables. Again, this could have been X1, X2, X3, X4. Daytime TV, evening TV, daily newspaper, Sunday newspaper, and radio. There's our variables. On this next quiz, you have to define your variables. You got to show the variables and put words next to it, what it means. The number of daytime TV ads, the number of evening TV ads. This is a big deal. Here's the objective function. No, wait. Oh, here it is. They have an exposure rating. The company wants to maximize the exposure rating. So we maximize 65 daytime ads, 90 times the number of evening ads, 40 times daily newspaper, 60 times Sunday newspaper, 20 times however many radio ads. And then our constraints. Oh, I almost forgot all these constraints. Let me go back to this. However many daytime ads we're going to do, We can't go over 15. That's all that's available. Evening ads, daily newspaper, Sunday newspaper. Every one of these is a separate constraint with the one variable that's represented there. So that's what you're seeing right here. Daytime TV has to be less than equal to 15. Now, I know these are spread out to try and keep the variables in place. This should be really right here. Daytime TV less than equal to 15 right here. Evening TV less than equal to 10. Daily newspaper less than equal to Sunday newspaper, radio. So there's those. Here is the budget. Every advertisement choice that we could have times the cost of it. $1,500, $3,000, $400, $1,000, $100. There's all five of them. Radio ads are cheap. $100. Then we need at least 10 TV ads. The only variables that represent TV are these two, X1 and X2 in our case. Daytime and evening TV, when added together, need to be at least 10, because the client said that we want at least 10 TV ads. Then $18,000 is the most they want to spend out of that $30,000 on TV. They're asking for 10 of the ads, and they don't want you to spend more than $18,000. So it's kind of a combination plus and minus, but here's the cost of daytime TV. Here's the cost of evening TV. However many of each one times their cost, got to be less than $18,000. They told us they want to reach at least 50,000 customers. Each variable represents how many customers they can reach. Greater than or equal to 50,000. We don't have to do this greater than or equal to 0. We know these are all going to be non-negative variables. My question for you is, how many Sunday newspaper ads, half-page color ads, are we going to present to the client that we are suggesting as an optimal choice with the limitations we offer? How many? 4. Huh? 4?
Well, that's how many you can.
No, how many are we recommending? The optimal solution for a Sunday newspaper. So how many are we recommending that they should do? 2. SN. All right. How many evening TV with the highest exposure rating? How many evening TV ads? None. Wait a minute. No evening TV ads. It has the highest exposure rating, which is what we're trying to maximize. But the cost you're going to pay, obviously, as my guess as to why it's not showing up in the optimal solution, the cost you're going to pay compared to that high index number is obviously not a good value, because in order to maximize, here's the highest we can get, the quality index number right there. That's what we're maximizing. Says we don't do any evening ads. Now, I want to tell you what's probably going to happen if this were reality. Your client's going to say, we like everything here, but we really would like at least two evening TV ads. What will happen to their quality exposure if we add 2 TV ads? Anybody see it? Who? Huh? What's reduced? Our quality exposure? It is. By how much? Anybody? Come on. That's right. Here's what's happening. Here, listen to the question again. There's the optimal solution, but the optimal solution says 0 evening TV ads. 0 of them. The client said we want at least 2 of them. We want to stay with you have here, even if it increases our budget. We like everything we see, but we want at least 2. No, matter of fact, nothing else is going to change. We want 2 TV ads. 2 of them. Look at the reduced cost. I think it's is that 65 or 85?
That's a 65.
65. So, go ahead.
I have a question about the objective function. So, the X's in the objective function,
Yeah.
maximize 65X.
X1 though is really DTV.
Is that a quantity of advertisements?
This
or
is
is
how
that,
this X1
is
or
that-
DTV is how many daytime TVs you would have, how many you're gonna schedule.
it should be customers impacted, or customers.
No, is it wait?
It
It's
should
telling me
be,
the objective
because
function
that would
is
be-
customers impacted.
It should be.
This
because
represents
that-
customers reach
Yes.
50,000. That's covered here in the constraint. They want at least 50,000 customers potentially reach.
Well, they're asking for the wrong thing.
In reality, maybe.
Yes.
But their concern is they wanted, for some reason, and you got to remember, you may go ahead and suggest, you're sure you want to have quality index as your objective here to maximize that, and you may say, you know, we really feel that you come out ahead maximizing the amount of customers you reach.
Well, it's not maximizing customers' reach, it's maximizing the quality per customer reached.
Well, hang on there. That's exactly what's happening here. This is maximizing the quality index. I don't know.
It should be based on,
What you're saying is, if
Shouldn't
this
it
were,
be based
he's saying
on
if this is
quality?
real,
yes.
that you should take
You should be
this
adding,
quality index and divide it into how customers reach. Like this, how many customers do you reach per one quality index, right?
Multiply.
I was thinking something
Just you
different.
have
Instead
to
of
have
adding,
some function that takes both variables into
instead of
account, I
taking
think.
one advertisement
If you
as
want-
one for X,
Yeah.
it should be multiplied by customers reached. That way.
So wait a minute, stop. If you're trying to maximize customers' reach, it would be multiplied by number. So however many daytime TV times 1,000 would be the amount of customers reached. So that's an objective. You can have that as an objective, maximize the number of customers reached. But then they would turn around and say, and we want the quality exposure to be at least.
Well, we keep the quality.
Quality exposure is
65 times.
Oh, you want to take,
Yes.
let's say we're doing 2 ads.
Yes.
2 times 1,000,
Two
which is
times
2,000. 2,000 times that.
Correct. That's what I.
You want to combine them.
Yes.
Yeah, you can do that. You can. Yes. In real life, that'd be possible, yes. Sure. It's very, actually, that's the same as taking 1,000 divided by 65 and
Yeah.
maximizing it.
100%.
You're breaking down how many you're reaching per gaining one quality index.
Yes.
Yeah, same thing. Yes, it can be done. For this story, though, we gotta stick to the story and maximize quality rating, but you can do that with anything. You may have a customer says, I wanna tell you, if I'm a customer, I wanna spend as little as possible. I wanna reach at least 50,000, I want a quality index of at least, whatever that number was on the max, a little below that maybe. I have limitations on those items, but my particular number one item is, I wanna spend the least possible for this campaign. And then the objective function would be a min, how many of each one times their cost.
Yes.
Yeah, you can do it that way. You can even combine cost per customer reach, which in your case, you would take TV ads times number of customer reaches times cost all in one step there, or divide the cost by the number reached to get the cost per each customer reach and make that your objective function. Same thing, does the same thing. So there's all kinds of ways you can approach this, absolutely. And it's all based on that conversation with that customer. Even when you're making recommendations, you still got to do it the way the customer asks, because they're the ones paying you for the job. So that's reality too. Don't get me wrong. You're saying, look, I think you do a lot better if you this, but you easily can run into where no, we've thought this through. We want the highest quality exposure.
It's also possible the exposure probably already takes into account how many.
Possibly, that's right. And which was in this sentence right here. Good point. Where is it? Is that it right here? The quality rating and exposure quality unit as a measure of relative value for the advertising. The measure is based on their experience in the advertising business, and it takes into account the audience demographics. Whoever it is we're reaching. Now, you remember at the beginning of this, it said they want to reach the upper middle class income type level people because of the cost of these lots to build houses on. So the advertising firm, when they're giving it that quality index, are taking into consideration we're reaching that audience that the customer wanted, their education level, because usually, by the way, all of you sitting here getting a bachelor's degree will pay you tenfold in the additional income you're going to make after you graduate. And had you followed the same path in a career without the degree, you're going to make that much more because you went and got this piece of paper. So there's your education factor, meaning you're going to be higher income possibly, of the audience reach. So these are taken into consideration of it, is what he's saying. And still then going with just the quality index possibly. But what this class is about is you being able to tell me answers to questions on these results. And I want to go back. The customer said, I want at least 2 evening ads. You would take 2 times, you everybody see the reduced cost. No matter if this is a negative or positive here, the $65, it's a negative impact. A negative, you got to look at it as negative. These are always negative. Remember for that last lecture, before the quiz. These are always negative. So, look at that $23.70. 2 times 65 is $130 or 130 something. Are we adding or subtracting it, excuse me, to that 2,370 if the client's insisting on these two ends? Why are we subtracting? Because it's what? Oh, you had it. Because it's what? Because what? No, no. Why are we subtracting? Because it's what kind of an objective function? It's a max. Because it's a max, a negative effect would be subtracting. So 2 times 65 subtract. We are heading this way. You will have a question that says the client's insisting. Anytime you have a 0 in the optimal solution, you're going to have this reduced cost here, which says if you want to force me to change, and by the way, here's how, in reality, here's how you force those two. What's the variable? E, T, V greater than equal to 2 is a new constraint you would then enter into the program and rerun it. And it forces at least 2 in the ends. To stay on budget though, to stay within this 30,000, to stay over 50,000, to only spend 18,000 on TV, and make sure we have 10 TVs, it's going to take away an advertisement in another area. Maybe 1, maybe 2, because we're adding 2 in the evening TV. So you have to rerun the whole thing to get the new optimal solution. And this will be, what is that, 65 times 2, 130 less. If you're willing, and you say to the client, we'll get you 2 evening TV if you're okay with your quality exposure being reduced by about 130. So that's the trade-off. And that's how you read that reduced right there. Let's do another. We got another one to do, but I want to make sure you get this output. We're that late right now already? Let's go on to the next one. Okay. Here we go. Well, here it is. 10 of those, 25 of those, blah, blah, blah. Look how much they're spending. 30,000. So if we force 2 evening TVs, since we're right on budget, something's got to be taken away somewhere to stay on 30,000. So we're losing advertisement at another spot. What does it say about 2370s our quality, total customers reach 61.5. We don't see the bottom half. Oh, I know what. There we go. Boom. Almost forgot. I put this all together. Yeah, remember this is a brand new PowerPoint, so I've had a lot of work putting this all together. So this is brand new, and this has been posted. Look at what I did. Constraint 1, constraint 2, constraint 3, constraint 4, constraint 5. There we have to, is all that's available. These are all less than equal. Here's our 30,000 budget. Here's at least 10 in the TV. Here is 18,000 spent on TV at the max. Here is reaching at least 50,000, and here is the quality index in our objective function. If you had a question on a quiz, and maybe if you were to sell blankety blank, blankety blank, what would be right there? And that question's asking that. If I were to put right there, what is that going to say? That's the answer you have to come up with if you have this Excel spreadsheet on your quiz. What would be in that cell? That would say equals E15 times E18 times, it's all the objective function numbers times the optimal solution added together. That's what's being maximized. If I said constraint 3 right there, this was similar to the one on the quiz, right? What would be typed in right there? You go to constraint 3, it would be all of these numbers times the optimal solution added together. Let's take a look. E8 times E18, F8. Notice the E8 has no dollar signs. The E18 does have dollar signs. That means when you go to copy and paste it to the cell below, it will still keep E18, F18, G18, H18, I18, but the E8 turns into E9. The F8 will turn into F9 and so on, because it did have the dollar signs. When you copy and paste down, all the ones with no dollar signs will go in numbers down. So that's how you use the dollar signs. It always means when you copy and paste, you don't want that cell location to change. You want it to always be E18, F18. And then you copy and paste, you write it here in the first one, copy it down 8 cells, and they're all written by only writing the first one using the dollar sign correctly. Because all of them have to refer to these cells. They just keep changing these. Ready to solve it? Here we go. Data. Now what do I do? Solver. All right? Is E20 where the objective function, you can't see this, can you? Hang on. Hang on. Let me see if I can do this. No. Okay, can you see it? Here we go, data solver. Is the objective function calculation taking place in E20?
Yeah.
All right. Where we want the optimal solution to appear for the variables, are they in F through I 18? There they are. It is 18, the row 18. Here's our constraints. It looks like E22 through E27, all the way from here to here, are all the same, less than equal. They are all less than equal, so they're all grouped together since they were all less than equal right in a row. Then the next one's a greater than equal, the one after that's a less than equal, the one after that is a greater than equal. They had to be done individually because they weren't in a row. There they are. And now we got to make sure this box is checked, simplex, it's solved. We want a sensitivity. I can't remember if we want this, just in case. Let's go all of it. Okay. Blah, 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 blue, bling. Here you go. Again, no evening. There's our 10. Blah, blah, blah. And here we go right here. My question for you is, again, I can't get to the right side to get this open up. My question for you is, I gotta look here, I think. Yeah. Okay. Daytime TV, is that what the fourth one is? Wait, I see what the fourth constraint is. 1, 2, 3, 4 is 1, 2, 3, 1, 2, 3, 4. That Sunday newspaper was supposed to be less than equal to 4. Okay, so now, you ready? Look at this. I'll make sure you're ready for this. 1, 2, 3, 4. How many Sunday, no, not how many. Yeah, how many Sunday TV ads, that full page newspaper ad, Sunday newspaper ad are we scheduling? Sunday newspaper, anybody see it? How many? Heard one. Look at the optimal solution. Which one's Sunday newspaper? This one right here. 2 of them. But look at the constraint for Sunday newspaper now. When you go here, do you see it? Right here. The fourth one down right here, E25. Notice it says final value in the solution 2, but the constraint said 4. That was this constraint where we only had 4 available. That's what it was. That's why it said we wrote the constraint if we had written it up here, less than equal to 4. The difference is either slack or surplus. What is the difference from the amount of Sunday half-page ads we're running and how many were available? What's the difference? 2, slack or surplus. Look at the constraint. Slack or surplus? Slack. Because the constraint read, however many Sunday newspapers, no more than 4 of them, less than equal slack. We only did 2. Let's look at let me see here, television. We were asked to make sure there's at least 10 of those. That's constraint, well, whichever one had a 10 for the original value. So let's look at the constraints. You see the one that had 10 as the original value, and how many are scheduled out of 10? Constraint what? No, stop. That's not it. Constraint 2 was there's only 10 available. Only 10 available of evening ads. What constraint is it that's a combination of daytime and evening ads combined need to be at least 10? You see it? Anybody? This one. There's the right-hand side of the constraint 10 that said the customer said we want at least 10 TV ads. How many are scheduled TV ads? 10. 0 slack or surplus. 0 slack or surplus. Surplus, greater than equal to 10. But again, you're totally not into this. Am I recording this? So let's just go to this one. Marketing department, A lot of marketing firms offer market research. This happens a lot when someone's thinking about branching off with this new thing or an expansion of some kind, and they want a market research done to make sure the potential's there to make money. So a market research company will come in and say, you know, we'll go out there and collect the data, analyze the data for you, and give you, documentation and a presentation so you know exactly what the market's out there as to what you want. Research firms found an objective in the survey, and they're saying the client needs it at minimal cost. What did you just read?
Objection.
The objective function is to minimize the cost. All right, so here's our options, and where is it? They want to have households interviewed by our marketing company, whether it's phone or door to door or whatever takes place, and they want you to interview households during the day. They want you to interview households in the evening, and they want a certain amount of households that have children living at the house, and a certain amount of households that don't have children. So before you go through the whole survey, whoever you just call, you're going to say, is this the decision maker of the house? Is there children living there with you? Yes or no? And then you've got to know if it's day or evening that this is taking place. How many different types of interviews have to be done? How many? 4. So you would have 4 variables, and you would define them. I'm using X1 and X2, X3, X4. We'll figure out what they're using in a minute. X1 would be the number of daytime households with children. However many we're going to do with those. X2, the number of households in the evening with children. Maybe could be the next one. The 3 could be daytime households with no children, and X4 would be evening households with no children. Now we have to hire people because we got to do. They want at least 1,000 interviews. So we got to get 1,000 of these done as fast as possible, and we have to have all 4 of these types because they want evening, they want day, with and without children. You get 4 decisions to be made, but the decision is, before we attack this, before we have our employees start gathering this data, they all need to know how many should they be doing during the day, how many should they be doing at night. When they get to how many with children, when do they stop and just focus on without children, or vice versa? They need to know how many of each one, and that's the decision. But they're asking, the client says, we want you to do 1,000 interviews. They didn't say at least 1,000. They want exactly 1,000 interviews. All right, so there's 4 variables: less than equal, greater than equal, or equal to 1,000. This is a question. That's right. Equal 1,000 is the right-hand side of that statement. They asked us, as the marketing firm, that they want at least 400 households with children. Less than equal, greater than equal, or equal? Greater than 400. This variable would be whatever variables represent households with children. So there's 2 variables. Daytime households with children, evening households with children. They want to interview at least 400 households without children, greater than equal to 400, but this time the 2 variables that represent daytime households without children, evening households without children. Total number of households interviewed during the evening must be at least as great as, now here we go. My advice on these, especially these when we get to recording this right here, try to write it exactly like the words have. And remember, of means times, usually. Of means times. Matter of fact, I'm going to jump to this one. I know we're running short on time. I want you to see this. At least, greater than equal, at least 40%, 0.4 of, let me read this, of times, this is Excel, I got to put a star here, right? Can't remember. Is that true?
I don't know.
I can't remember.
No, it's a dot.
Stop. I think you can leave it just right next to it, but I don't know what I'm thinking. 40% of the interviews for households with children. 40% of, so let me say it again, at least 40% of the interview, at least 40% of the interviews with children. So this would be whatever two variables are with children, because there's two variables of households with, two variables of households without. At least 40% of the interviews for households with children must be conducted during the evening. We gotta get our variables here so I can do this. With children is DC, daytime with children, EC, evening with children. You ready? So this is daytime children plus evening children. So there's all of them in the evening. At least 40% of all the interviews with children have to be conducted in the evening. The evening with children interview amount, however many you're doing here, has to be greater than or equal to 40% of all the with children interviews. See how I came up with that? I suggest it makes it as easy as possible if you just follow the way it reads and kind of count the word of as multiplication. Now we're going to do the other one. Help me through this. At least, what do I start with? Greater than or equal. At least 60%, 0.6 times. At least 60% of the interviews for households without children times without children, hang on. What's in here? All the interviews without children would be in the parentheses, because 60% of all the interviews without children. What represents without children? D and C plus E and C. No children, no children. So at least 60% of all the households, at least 60% of the interviews of households without children must be conducted during the evening. So this would be E and C, greater than or equal to 60% of all the with no children interviews. You got to get to the point where you read these, and your next quiz, you may have only this sentence right here with the variables above it, and you got to write that constraint. And my suggestion is write it the way it reads. Just keep marking it with each part of it. All right, we're there. We're going to pick up from right here then. Because we didn't come on Tuesday, we're coming Saturday, right?
Yeah.
No, we gotta watch the Michigan game.
We'll have the Michigan game here, and then at halftime, you go over this again. Afterwards, you complain about how
Only
we
if
should
we get
do it,
Halloween
and then
off.
we go over more.
Only if we get Halloween off.
Yeah, okay, happen.